Okay, so I will share my screen. Hope you are all able to see my screen, right?
Yes,
Are you all able to see the question paper? Can you unmute and tell me?
Yes,
Yes,
sir.
sir.
That's great. That's great. Okay. Let us solve some questions today. Fine. Okay. Now, this is the questions from second semester 2023 of midsem. Okay. So, let us go to the first question. Now, see here. This is the conversion question. Assume 16-bit mode of operation. Write the machine code and its respective addressing mode. And what is given here? You have to write the answer in hexadecimal to get the marks, because some students will simply write the binary and then leave it there itself. That is not accepted, right? See, this is carrying 2 marks. See, each question carrying 2 marks. 1 mark is for the machine code, another mark is for the addressing code. Now, this is the question. The question is move cx, comma pp plus 1000h. If at all you have done these mistakes, done any mistakes in solving this, see that you will not do it in your midsem examination. Okay, so in the question paper you will have this table as it is given this time in the quiz. This will be given to you. Okay, this will ease you to get the machine code or assembly code conversion done, right? Okay, so as usual, I think if you really have a practice, I don't think you will have any difficulty in this, right? So first will be opcode. Opcode will be what? Opcode will be 100010. Hope all of you know this. Is it fine? Then comes your D bit, right? So here data is going to the register. Data is going from memory to the register. It is data is going to the register. Okay. Now when the data is going to the register, you all know that what is the D bit, right? Okay. What is the D bit? That information will not be given to you as a manual. You need to remember that. Okay. So can you tell me what is the D bit if the data is going to the register? Can somebody unmute and tell me? No problem. Somebody unmute and tell me. What is the D bit? Are you all able to unmute?
1.
D bit is 1. Okay. Right. D bit is 1. Okay. Now, what is the W bit? Next is W bit, right? W bit is 1.
It's 1.
Okay. Because it is 16-bit. Okay. Now, immediately what you can do, you try to include the register bit. Which register is that? Right? Once you put D bit and W bit, then immediately try to put the REG bit, which is coming after mode. So for that, you have to see this table. See this table. Okay. You have to see the register table. Say this is the register table. Right. So what is that code for CX? CX is coming here. Can I say CX is coming here? The code for CX is 001. So it will be 001. Have you understood this? Okay. Have you understood this? Okay. Now, what is your mode bit, which will come here, and R by M bit? So here it is R by M bit. It is memory here, right? It is memory. It is not register. So you have to look at the table where you have BP plus D16 like this. BP plus D16. Let us see the table. Where do you have BP plus D16? See, can you see here? Can you see my cursor? If you can see my cursor, you can see I have put my cursor on BP plus D16. What is the mode bit for BP plus D16? Mode bit for BP plus D16 is 10, right? Just go to the top, mode bit you get, and come to the left. For BP plus D16 it is 110, right? So mode bit is 10, R by M bit is 110. So it is 10110. It is here 10 and 110. Right? Is this done? No. Right? First, let us write the hexadecimal equivalent of this. What is the hexadecimal equivalent of this? This is 100. You make a group of 8 bits and then put its equivalent hexadecimal value. So this is what? This is 8, right? This is 8. This is 8, 100. And what is this? 1011? 1011. Some of the students who did this mistake in the quiz, they have actually not properly converted these hexadecimal to this binary to the hexadecimal, right? So 1011. See, 101 is 10. It's 11, right? It's 11. 11 means it is B, right? Okay. After that, okay, after 1011, you have 1000. 1000 is once again 8, right? 8. And after that you have 1110. What is 1110? It is E, right? It is E. Then comes this displacement. This displacement, lower byte will come first and upper byte will come next. So last you put H, indicating it is hexadecimal value. This is the answer. And remember, it is asked 16-bit mode of operation. Since it is 16-bit mode of operation, there is no violation at all. This is also 16-bit. Address is also 16-bit. Hence, both are 16-bit, right? There is no violation for the 16-bit mode of operation, as the question is asked for 16-bit mode of operation. See here, 16-bit mode of operation. Okay, this is the answer. Say this answer. 8B, 8A. Suppose if you have asked to do same thing, this is for 16-bit mode of operation. Okay, 16-bit mode of operation. Hope everybody is able to do this. Those who are present now, hope everybody is able to do this. Suppose what is the equivalent 32-bit mode of operation machine code for this? There is a violation. If it is 32-bit, there is a violation. This is 16-bit. Address also there is a violation. Both register violation is there and address violation is there because it is 32-bit. So the same code, for the same code, you have to add 66 and 67. If it is asked for 32-bit mode of operation. Have you understood this? Okay. So this is for 32-bit mode of operation. Okay. And this is for 16-bit mode of operation. This is the answer for the first question. Okay. See, don't do any mistake in the comprehensive examination for this. Okay. These conversions and all, never do any mistakes. Okay. Now, let us take the second one. Okay. Let us take the second one. Now let us see what is this. Are you all doing it along with me? Just consider it as a practice. You're doing practice.
Yes, sir.
Right? Okay. Now, as usual, start from here. Start from here. Opcode 1. Sorry, I'll go to the next line here. 1 0 0 0 1 0 because opcode is okay. Now once again here D bit is 1, right? Why D bit is 1? Because data is going to the register. Data is going to the register. Okay. Register is 16 bit. There is a violation. We'll think about it. Adding one prefix at the once you get our machine code. Okay. Now anyway data is going to the register. Okay. So D bit is going to be 1 and W bit also is going to be 1. Immediately you put reg. You put reg bit. So what is the reg bit? It is ECX. Reg bit for ECX. Okay. So go to the refer to your register table. When you refer to register table, ECX is coming here. That is 001. ECX is 001. So I'll go here. I'll put ECX as 001. Is everything fine? Now, what else? Now you have to refer. See, there is a overriding is also here. So this overriding also you need to mention in the prefix. Okay. So now you have to refer to this memory. Memory is within the bracket PX, right? So you have to refer to R by M and mode table for this memory. Okay. Register is already done. Register, it is actually data is going to the register. See, data is going to the register. You have put D bit is equal to 1 and this is more than 8 bit. So W bit is going to be 1. And which register is that? That we have indicated, that is ECX register from the table 001. So what is left is mode bit and R by M bit corresponding to this. Now where you have to refer? You have to refer to within the square bracket BX. Let us go to the table. Okay. Now where do you have within the square bracket BX? Can you see here? Can you see here? Here you have within the square bracket BX. And can you tell me what is the corresponding mode bit? Corresponding mode bit is 00. Right? What is the corresponding R by M bit? Corresponding R by M bit is 111. Right? So 00111 you have to put in place. Okay? 00 and 111 R by M is 1 by 111. That's all. That's all. You got your machine code. You just have to fix the prefixes for this. Okay? Right? Now, what is the machine code, corresponding machine code? Try to make a group of 4 bits and convert it into hexadecimal. So what you will get? First, it is going to be 1000, that is 8. And after that, it is 1011. Once again, it is B. Okay. Okay. And then after that, you have 0000. It is 0. And then F. Then F. Because it is 1111. Right? Now, what is that violation here? There is a register size violation because it is asked for 16 bit, right? It is asked for 16 bit. So because there is a register violation, you have to put it as a 66. Okay, and there is a overriding here. There is a segment overriding. Segment overriding is SS. So you go and refer to this table. What is that prefix you have to put for segment overriding? See, this is for segment overriding prefix. Okay, so for SS segment overriding, the prefix is that 36. Okay, it is 36. So you just have to fix that 36 here. 36 here. Okay, fix that 36 here so that your complete answer, you got it. This is for 16-bit mode of operation. because there is no address violation, right? There is no address violation because address is 16-bit only. So 67 will not come here, right? Now this is the answer. Now suppose if you want to write 32-bit operation, if you want to write a machine code for 32-bit mode of operation, okay? So what is that something you have to put for 32-bit mode of operation? There is no register violation, size violation, but there is a address violation because address is 16-bit, but you are asking for 32-bit. So in such cases, 36 will come anyway because you have segment overriding here. But here for 32-bit mode of operation, there is only address violation. So 67 will come, right? And remaining machine code will remain same. This will remain same. All of you understood this? Okay, this is for 32-bit mode of operation. Fine, right? If you do this correct, you get 4 marks, and definitely similar question will come, right? So have you all understood now? Anybody has doubt in conversion? See here, this is the answer. Right? This is the midsem paper came during 2022 and 2023. Right? Everything is fine. Right? Can I go forward for the next question?
Yes, sir.
Okay. Next question. Which of the following instructions are valid or invalid in 16-bit mode of operation? Listen carefully. Okay. Now, move ch comma ex. Is it valid? Is it valid? Don't see the answer. Is it a valid instruction? Don't see the answer. Just think. Why it is invalid for 8086? Because see, you are trying to take a 16-bit data from a 16-bit register and you are going to put it in a 8-bit register. There is a mismatch, right? The size, the data size of source and destination must be same. Data size of source and destination must be same. So this is invalid. Yes or no? Now come to the second one. Can you tell me this is valid or invalid? Add AXCL. Can you unmute and give answer? No problem. Let it be interactive, my dear students. Why you don't want to give answer? Right? Is it valid or invalid?
Invalid.
It's invalid, right? What about others? Why can't you give?
Invalid.
Okay. It is invalid, right? Because it is AX here. Once again, it is actually, there is a mismatch. Now see here, move CX comma, in the bracket CX plus 1000H. Why this is invalid? Now, whenever this type of instruction comes, okay, here there is no mismatch. Is there any mismatch here? No, right? Because this address is 16-bit. Okay, data from address, whatever data from address can go to CX register. But can you see that is there anything possible in the table? Is it possible that there is anything like any mod and R by M bit for this? CX plus It's supposed to be CX plus D16, right? This is CX plus, this is D16 means 16-bit data, right? You refer to the table now. Refer to the table now. Where is the table? Okay. Now refer, is there anything called CX plus D16 here? Can you see here? Do you have anything CX plus D16? Right? Okay. There's nothing, right? Is it there? No.
No, sir.
So hence it is invalid. Hence it is invalid. Okay. Hence it is invalid. This type of questions may come. Okay. By the by, I just want to tell you what is the addressing mode for this. What is this addressing mode? This is register relative, right? Register relative. This is indirect addressing mode. It is straightforward, right? Indirect addressing mode. Okay. So that you need to do, because if you don't do that, you will lose this mark, because this is 1 mark, this is 1 mark, this is 1 mark, this is 1 mark. Okay. Now here, this is very easy. You have to write invalid or valid. Okay. Now, see this. Okay. See this. See whether this is valid or invalid using 16-bit mode of operation. Right? Logic wise, this looks correct. Right? What it does, it is going to put the value into ECX register. See, you can say that because you are having one 32-bit register, you can say it is invalid because 16-bit mode operation. That's not the correct reason. Right? It will convert it into assembly code by putting the prefixes. Okay, you can convert this to assembly code, but when you convert this to assembly code, what is that something missing? Check whether you have this within the bracket AX. Right, everything has to be available, right, in the table. So look at the table now. If you look at the table, you can see that within the bracket AX is not available. Just check, is it there? Within the bracket SI is there, within the bracket DI is there, within the bracket BX is there, right? Okay, but within the bracket AX is not there. That means for 8086 operation, these instructions are invalid. You just have to check this. This is very important. Have you understood this?
Yes, sir.
Okay. So we are done with 2 questions now. Let us go to the next question. This is reverse conversion. Many of you have the problem here. Okay, many of you have a problem here. Let us do this. Don't worry. Okay, let us do this. Let us check how to do this. Okay. Now, this is the question to convert it into assembly code. Machine code is given. You have to convert it into the assembly code. Now, once again, it is said that assume 16-bit mode of operation. When it is assumed to be 16-bit mode of operation, okay, you have to check, okay, any violations are there, and then accordingly decide the register size. Okay. Now, look at the first few bytes. Okay. See, if there is 66 and 67, okay, if it is 66 and 67 means the assembly instruction which you are going to get has some violation when you consider 16-bit mode of operation. Okay. See, violation in 16-bit mode of operation means what? Definitely there will be 32-bit register and 32-bit address in the instruction. See, it is here, it is assumed to be 16-bit mode of operation. That means I am assuming that this instruction is for 16-bit mode of operation. And when you assume this to be 16-bit mode of operation, you have 66 and 67 both here. when I'm assuming it to be 16-bit mode of operation, and when I have this violation in my 16-bit mode of operation in assembly instruction, definitely there will be 32-bit register and 32-bit address, right? So definitely there will be 32-bit register and 32-bit address, right? So your instruction should have a 32-bit register and 32-bit address in it. Okay, so then you look at this subsequent 16-bit values. What is that? 8983. Then look into this. Don't look into everything. Don't convert everything into binary. So now look at this 8983. Okay. Now look at 8983. Now convert that into binary. So when you convert that into binary, you get 1000. Okay. Then we will have 1001 corresponding to 9, 1000, and you have 0011 corresponding to 3, converting it into the binary. Now you convert this into your assembly code. This is what your instruction format. Now, first 6-bit is corresponding to the what? Opcode, right? Yes or no? Opcode. What is that opcode? Come on, I want you to. Who is the opcode? Now, what about D-bit? What about D-bit?
From
D-bit is?
it's 0.
0. Okay. D-bit is 0 means what? Data is?
From the register.
Coming from the register. That means here you will have the memory, right? In this place you have the memory. We don't know what is that. Let us see. Data is coming from the register, right? Right. That means it will come after comma. It will come in the place of source, right? Okay. Now, okay. Now here 10010. Your W bit is 1, right? W bit is 1 means it is more than 8-bit. And now you know, because there is a violation for 16-bit, definitely the register will be what? Is the register 16-bit or 32-bit?
32-bit.
Register will be definitely 32-bit. There is a violation. That means you should look into the 32-bit register. You go to the table. Go to the table. Where is the table? So and which register is that? Which register is that? Tell me. Which is the REG bit? REG bit is this one, right? No, sorry. 000. Yes or no? This is REG, right? This is REG. See, I'll just try to put this space here. This is REG, right? This is REG. Okay. So look at the corresponding REG here. 000. What is that 32-bit register?
EAX.
EAX. Yes. So what will come here is EAX. Right. Now look at the mode bit 10 and R by M bit 011. Okay. This is your mode bit. This is the R by M bit. Accordingly, you will get the content inside the square bracket. Okay. Right. Now let us see what is that. It can be square bracket or something else. Let us see that from the table only, but still simply I put square bracket there. Okay, mode bit is 10 and R by M bit is 011. Refer to the table now. Refer to the table again. Okay. Now, which table to refer? Tell me. Which table to refer?
32-bit.
32-bit. Why? Because there is a violation there, right? In the beginning only, because of the prefix, you know that you have to refer to 32-bit only. That's why refer to this. Okay. So 01, right? 01 and 011. Oh, sorry, 10. Mode bit is 10, this one. And your R by M is 011. So 10011. Definitely it will be EBX plus D32, right? EBX plus D32. Okay. So then this displacement is already available in the instruction itself. You know that. Okay. So it is EBX plus D32. So I will put here EBX plus D32. Now tell me from where this D32 will come? From where the D32 will come? See the instruction. After 8983, you have this 32-bit displacement given here, right? You have this 32-bit displacement already given here in the instruction itself. So now put that here. So what will come first? Can you tell me what will come first? Because see, when it is stored in the memory, you know that first lowermost bit will come, right? Lowermost byte. Which is the lowermost byte? Tell me.
00.
00, right? Okay. So which is the uppermost byte? Uppermost byte is FF, right? So what will come is FF first. This will come first. Okay. See, this is what stored in the memory. When it is stored in the memory, it stores like this. Okay. This displacement is stored like this means it is the actual 32-bit address is FF001000, right? So you put it in a reverse order 001000. This is the address. I told you lowermost byte will be stored first in the memory. So that will come in the last, because we are going to put the actual address here like this. The actual address is FF001000. Now this is the answer. This is the answer. Okay. So let us check the answer. Okay. Yeah, move EBX plus FF000110. Okay. Let us check it is. Yeah, it is 01, not 10. Sorry, it is 01. FF0001, because it is 01 here. Okay. It is FF0001. Just EAX, comma EAX. That's the answer. See, you get 2 marks if you do this. See, 2 marks you get. Okay. And speed is very important. Now, can you convert this 8A1C? Do I need to do this? Those who are here, can you do it yourself? Okay, take it as a practice. Can you do it yourself? Check whether you get this answer. Okay, I'm showing you the answer here, but can you do this? See how much time it takes for you to do. Okay, how much time it takes for you to do. Right? Okay, can you do? So I have all students here, very good students. Practice it, practice it. This is going to be a practice for you now. Okay, see that this 2 hours you are going to practice for the exam. Okay, so that's why I'm just taking up these things for you. Okay, do I have to do? Because this is very easy. The machine instruction is 8A1C and it is to be converted into assembly instruction. Okay, so Now, because see, there is nothing here, no prefixes, nothing is there, right? Okay, this is something very straightforward instruction. So just do it as convert it into binary 1000. Okay, 1010, then 0001, and C is what is C? Tell me. Come on. What is the binary equivalent of C? That should come immediately for you. If you make a mistake, then definitely you will have. Okay, come on.
1100.
1100. Right? Okay. See, B means 11. C means 12. Right? 12 means it is 8 plus 4. Okay, 00. Right? Okay. So now you just try to make 1110. Okay, 1000. Sorry, 10011. Right? Wait, what's that? Is it correct? No, no. 8A. A is somewhere I made a mistake, right? A is 1010. 10. Right? Okay. Now try to make it as a group for you. D bit. Oh God, what happened? Okay, I'm just. Okay. Now tell me what is that opcode? This is opcode, right? This is move. Okay. Now D bit is 1. D bit is 1 means it is data is going to the register. That means immediately next you will have a register only, right? Okay. Now it is 8-bit data because it's 0. What is the REG bit? 011. Okay, refer to the table for REG bit. So REG bit. Okay, what is that REG bit? It is 011. 011 is, what is that? Tell me. Come on, I want to answer.
BX.
Who's given that answer? Is it BX?
The BX.
Hmm? Look at the W bit, my dear student. Look at the W bit. This is what you make a mistake.
BL.
It is a
BX.
W bit is 8, right? It is a
Yes.
8-bit register. It's not 16-bit register. Correct yourself.
Yes, sorry.
This is the mistake you do in the exam also, in the hurry. See, register is here 8-bit register because W bit is 0, right? So then in that case, when you write it from the memory, sorry, register REG bit, it is not BX, it is BL. It is BL. Be careful. This is the small thing you may lose your marks. I don't want that to happen. Right? Okay. So you normally say that silly mistakes, you have lost your marks. But this type of question, there is no step marks for this. I've understood. There's no step marks for this. Final answer will have the answer marks. That's why be careful. So here it is BL. Now mode bit is 00. Mode bit is 00, and then mode bit is 00, and then R by M is 100, right? Sorry, 100, right? 100. Okay. Now can you refer to the table again? Okay. So here there is no violation and all. Absolutely no violation. That means it is asked for 16-bit mode of operation. That means whatever you get assembly instruction, it is corresponding to have 16-bit uh, register or 8-bit register according to the W bit. Okay, and address is also 16-bit, right? That means you have to refer to the 16-bit this table, this table, 16-bit operation table. Okay, now it is 00, right? Here 00, mode bit is 00. What is that? Your R by M bit 100. See what is there correspondingly? Correspondingly, you have within the bracket SI, within the square bracket SI. So same thing, you just put it here. within the square bracket. Yes, I done. See, you will get 2 marks in this. I don't want anybody to do this mistake in the exams. Please, never do it.
Sir,
Right? Yeah,
sir,
tell me, any doubts?
sir, in the before question, if
Which question?
in this question only a bit,
Which bit you're talking about?
the one before this,
Huh.
that if r by m and mode bit are 100 and 10, then what should we do? Sir? It's scaled index.
No, if mode bit and
If r by m is 100 and mode bit is 10, then what should we do?
okay, suppose your question is suppose mode bit is
100.
no, how can mode bit 3 bit, man? Mode bit is 2 only, right?
No, r by m is 100 and mode bit is 10.
This one is
100.
100. Okay. This one is
10. That is
10 only. Okay, refer to the table. 10 and 100. 10 and 1. Okay, 10 and 100. It's a scaled index, right? Okay. Now, see, listen here. It is given here as scaled index plus D32. Right? In such cases, what happens? Then you have to refer to, then definitely you will be given 2 more extra bits here. In the question itself, okay, in the question itself, you will have, listen, see the question first, I'll tell you. In the question itself, in such cases, it is not given randomly, okay? See, in such cases, what will happen here is, in the question itself here, okay, you will have after this 8983, after this you will have another 8 bit 1 byte value corresponding to your, what is that, base, scale value, right? And then base and index. Yes or no?
yeah.
I've
Yes.
understood this. We cannot have that randomly, as you said, you put that 10 and 100. I've understood this.
Yes, sir. Understood.
If at all you just change that, okay, I've understood this. Suppose if at all I have to do according to what you said, okay, now tell me, I will frame the question now. Okay, I'll frame the question according to what you said. Okay, now in this case, okay, your question will be 66, 67. Okay, now see here, this will change now. According to your requirement, this will change. You said that you have to, you want to have that scaled index, right? Here, scaled index, see here, scaled index here, that is 10100. So I'm changing the question now. Okay, so I'm putting 10 here and 100 here. Accordingly, this will change, right? This will be 8, this will be 9. Now this will be again 8, okay, and then it will be 4, it will become 4. Okay, now next 2 bit, next one byte, next 1 byte here, it will be corresponding to the scale value. Okay, it will be corresponding to the scale value, and then base and index, right? Okay, that is what is actually for your scaled index, right? Scale value, index value, and base value. Okay, so accordingly, you will get one more byte over there, one more byte over there. Okay, see, suppose if I take, I will take an example. Say if I take your scale value as 2, okay, scale value as 2, and index register I will take some as ECX. Okay, I'll take it as ECX, index register, and then I will take base register as EBX. Okay, so accordingly you will have one more byte over there, okay, which is corresponding to scale value. What's the scale value corresponding to? 2. Okay, scale value corresponding to 2, I told you to remember, right? Okay, it is 00 for 1, it is 01 for 2, right? It is 10 for 4 and 11 for 8. Okay, so accordingly, you will have one more byte here, that is scale value 2. Suppose scale value 2 means it is 0, 1. Okay, I'm writing binary. Okay, and then you have a index. Index, I said ECX. So ECX index means ECX is 001. ECX is 001. ECX is 001. Then you have a base. Okay, base is how much? EBX. Suppose if you take a EBX, it is 011. Okay, it is 011. Okay, so can you tell me what is the hexadecimal corresponding to this? 0100. 0100 is 4, right? Okay, then 1011. 1011 is B. The same question is reframed again, right? Okay, for scaled index, then you will have this. You will have this displacement. Okay, your same question is framed like this. Now, if you convert this, can you convert this? What you will get? If you convert this, what you will get now? Tell me. Come on, convert this instruction. It will be moved within the bracket. Now it is scaled index, right? Okay. What will come here? E bx plus 2 star. Okay, come on, tell me. 2 star ECX. Sorry, ECX plus D32 plus D32. It is scaled index plus D32. So this is corresponding to scaled index plus D32. What is the D32? Come on. FF 0001 Okay, comma the same EAX. See, now this is what you get. Right? So someone asked questions that what happens if you give 10 and 100. Definitely it will become scaled index, but same time in the question there should be separate extra byte is given corresponding to the scale value, base index value and base value, and then you have a displacement here. Okay, so accordingly you get this as the instruction. Understood this? Right? So see, according to whatever machine instruction given, you simply convert it. That's all. Right? So when you convert this into machine instruction, definitely you get mode bit as 10 and R by M bit as 100. Right?
But why are there two ones in that?
Where two ones?
After FF00, you put two ones. Why is that?
It is FF0100, right? Yeah, it is 32 bit, right? Now it is 32 bit.
Okay.
Yeah, one extra one has come there. Yeah. Fine. Okay. See, especially those who are having some confusion in scaled index, do multiple problems of scaled index. Okay. You may get questions on scaled index also. Don't do any mistakes, because these are the places you can score marks. Because I know that when it comes to programming, you will start struggling. At least do these things properly and then come to the program. Always in the exams, don't do a mistake of attempting program first. You will never be able to complete. That's why you do all these conversion questions, basic questions first, and then you go to the programming question. Have you understood? Everything is fine. Are you all there? You're not there. You're there, right? Or sleeping? Hope everybody is there, right?
Yes, sir.
Getting sleepy?
No, sir.
Fine, no problem. Okay, very good, very good. So parallelly you make a note of all these things. Okay, it will be helpful for your exams, right? Okay, let us go to the next question. I will try to do as much as possible questions from this paper. Okay. Yeah, this is very easy. See, this is very easy question. 4 marks. 4 marks comes here. Very easy, right? Okay. Now listen. You know about flag register, right? All of you know about flag register. You know flag register, right? Okay. So you know when the carry flag will become 0 and 1. You know, right? Right. Whenever there's the add operation, and after the add operation, if there is a carry flag will become 1. You all of you know about it, right? Okay. Now you know what is the 0 flag. What happens to the 0 flag? Whenever you use a compare instruction or subtract instruction, if the results are 0, then 0 flag will be 1. Otherwise 0. You know that. Sign flag. You know that most significant bit. Okay, so whenever you do something move operation or move operation, no flag will be impacted. You know that you can directly write the answer, right? But whenever you do arithmetic operation, okay, your result may be negative sometimes, right? In such cases, you can see that your value will most significant bit value will be 1, right? Of the result will be 1. Overflow flag, overflow flag means whenever you do any add operation, subtract operation, anything, if the result goes above the 16 bit or 8 bit, right? In that case, overflow flag will be set. Okay, that's why. And parity flag, right? Whenever you have even number of ones, it will be even parity. Okay, I've understood this. Otherwise, it won't be even parity. I've understood this. So accordingly, you just auxiliary flag. If there is a carry coming from the previous nibble, you know that, then auxiliary flag will be set. Otherwise, auxiliary flag will not be set. Okay. Now you see here, first instruction, move BL, 13H. You have seen, and we have explained you in the class that move instruction will not impact any flag register. Flag register will not bother about this move instruction, or move instruction will not bother about flag registers. Nothing will happen in the flag register during move instructions, right? Okay, so you can see that, write the answer as no flag impacted. Similarly, here also no flag impacted. But now you see here, add AL comma FFH. See, now, see, of course, AL content now, see, because of this movement, can you see here, AL content is 0, 0. Okay, AL content is 0, 0 according to here. But you see here, whatever be the value of AL, okay, whatever be the value of AL, okay, now see here, what happens here? Auxiliary, see, it is, you can see that, of course, carry flag will be 1. Yes or no? Right? Carry flag will be 1. Right? See, what is the content of AL here now? AL content is 08, right? See, this is, you are putting 0008 into AX register, right? Now, 00 is the content of AH register. 08 is the content of AL register. That means when the execution comes to this instruction, your AL is having 08 and you are adding the 08 with FFH. Okay, so you are adding 08 and FFH. Definitely F plus 8 will give you 1 carry. Yes or no? This is one nibble. This is the nibble of this AL. This is the nibble of the F. So when you add F and 8, this is one nibble, right? One nibble, this 4 bit, right? So AL is 08 now, and you are adding it with FF, right? So now I can explain you that here. See, AL content is 08 from the previous instruction, because you are putting 0008 into AX register. That means the higher order byte 00 will go and sit in AH part of AX, and lower order byte will sit in the AL part of the register AX. That means 08 is there, right? Now you are adding it with FF, right? F. That means what type of addition is this? This is actually addition. This is, if you write in a binary, this is 0000 and it is 1000, right? And then FF means 1 1 1 1, okay, 1 1 1 1. So when you add this, okay, so what will happen? There is one carry coming from here, right? 1 1 1 1, one carry will come. You can see this is previous nibble. There one carry coming from the previous nibble. When one carry comes from the previous nibble, automatically auxiliary carry flag will be set. It will be 1. Okay, and then when you add this, definitely you will get one carry after this. Okay, then 1 plus 1 carry 1, 1 plus 1 carry 1, 1 plus 1 0 carry 1, 1 plus 1 0 carry 1, 1 plus carry 1. Last one extra carry will come here. So because of that, carry flag also will be 1. Right? Okay, is the result 0? No, result is not 0. Right? Okay, I've understood this. Result is not 0. Now, can you tell me, is the what is the parity? You have to check that. If it is number of ones are even, then definitely even parity will even parity, the parity bit will be 1, right? So like that, you can tell the status of the flag register when this instruction is executed, right? So now let us go to the instruction. Now instruction is add ALFF. Definitely you have understood now that auxiliary flag will be set and carry flag will be set. Zero flag will not be set because result is not 0. Sign flag is not set because most significant bit is not 1. Overflow flag is 0 because result is not going above 16 bit, right? That's why overflow flag is 0. Then parity flag is 0 because number of parities is okay, even parity, number of ones are even. Okay, so like that you can just check, okay, check the values of the result, and same time you check that result and you decide whether the flags are set or not. Okay, so now see here, if you see the result, I'll just go here. What will be the result here? Okay, tell me. The one carry coming here. Okay, then what you have is 0 0 0 0, and then here you will have a 0 here. Yes or no? Right, then you have a 1 1 1.
So,
right?
so overflow flag will be set to 1, right?
Overflow flag, see, this is 16-bit register, right? Since it is 16-bit register, see, only carry flag is set, right? There's no overflow.
Then
right?
what overflow flag?
Overflow will not be set. How overflow flag will be set?
So like
Overflow, yeah,
overflow.
carry will be set. That's all. Carry will, this carry can be accommodated in AX register, AH register, right? If you want to the program. That's why overflow flag will not be set.
So like when will overflow flag will be set? Like
Yeah, definitely. When the addition goes above 16 bit. You understood?
Okay, understood.
Right? When the addition goes above 16 bit, definitely overflow flag will be set. Right? Okay, so now you can try for the next instructions. Next instruction. Now, next is subtract AL, FFH. Okay, now instead of doing this addition here, you do the subtraction. Right? Definitely there will be borrow, right? Yes or no? Is there any borrow? There is a borrow, right? Because 08 minus FF. So when I say there is a borrow, means carry flag is set. Yes or no? Right? Carry flag is set. Then check that borrow is getting forwarded to the next nibble. You check that. If the borrow is forwarded to the next nibble, then there will be auxiliary flag set. Right? So accordingly, you write the answer here. Okay. See here. Carry flag is set. I think there is a borrow going from the first nibble to the next nibble when you do the subtraction. Because of that, auxiliary flag also will be 1. And remaining all the flags are becoming 0 here. You can check, result is not 0, sign flag is 0, overflow flag is 0, and parity flag is also 0. Right? Okay. Now it is subtract operation. Now AND operation, AND operation, AND AL BL. Okay. Can you make AND AL BL? What is there in AL? What is there in AL? What is there in AL? Tell me. Now see, you have to be very careful here. See here. Now, when you do this add instruction, say which AL content you have to see. Come on, tell me which AL content you have to see. Are you going to see the AL content of whatever you have seen here? See here, your AL content is changing, right? Yes or no? Come on. Come on. Tell me. This carries 4 marks. See here. When the add AL, FFH is executed, your AL content is 08. Okay. Now for the next instruction, subtraction, what is the AL content? Tell me. AL content is this one, right? Yes or no? This is the AL content.
Yes, sir. Yes, sir.
AL is this one. So what add instruction is doing here? Your add instruction, add AL, comma, it is given as FFH, right? FFH. That means this instruction is going to add 8, okay, which is the content of AL register. Hope all of you understood why AL is 08, right? I did not tell you again. Then result is stored in which register? Register where the result is stored. Come on.
AL.
AL only. So AL content is now 07. Yes or no? Now next instruction is subtract AL, comma, what is that value in the question? Subtract AL FFH. Subtract AL FFH. Right? So now what is the AL content now? What is the AL content now? Come on, tell me. Don't be lazy. AL content is 07, right? 011. Right? So you subtract 07 minus FFH. This is what you're going to do. You are going to subtract 0000, 0111 minus 1111. Then you have 1111. Now subtract. Can you subtract? Come on. I don't see any answers coming. What will come here? Tell me. Hey, make it interactive. Why can't you do subtraction, binary subtraction? You just have to refer to your previous DD. What comes here? 0, right? Hello? Are you there?
Yes, sir.
I'm not understanding. Are you doing it or not? Or simply my time is becoming waste here? 0 here, right? Then 0 here, right? Okay, now tell me. There is a borrow coming, right? Yes or no?
Yes, sir.
Yes, sir.
Okay. Then everywhere you get a borrow right now after this. Yes or no? Yes or no? Come on.
Yes, sir.
Definitely you can see that your carry flag and auxiliary carry flag is set because of this. Right? Yes or no?
Yes, sir.
Yeah. Okay. So I will leave it to you what we are going to get here. Okay. Now definitely you can see there is a borrow coming from previous nibble to the next previous nibble, or here I can say this next nibble to previous nibble because subtraction, right? So because of that, I can say that your auxiliary flag is going to be 1 and carry flag is going to be 1. Okay, and you can see that 0 flag is 0 because the result is not 0, and then you can see that your sign flag is actually also equal to 0 because most significant bit will be 0, right? So sign flag is 0, and also you can see that number of ones, right? You know that what happens to the parity flag? Parity flag means when even number of bits are there, it will be 1. Odd number means it is 0, right? Okay, remember that. Okay, that's very important to remember about flag registers. You have to know when it will be setting and when it will be not setting. So you will get something into AL register, right? Now use that content of AL register for the next operation and in AND operation. And you know, whenever you do AND operation, definitely there is no carry flag and auxiliary flag. Yes or no? There is no carry flag and auxiliary carry flag. Now see, 0 flag is 1. See here, if you see, if you do the arithmetic operation here, everywhere you get 0, right? Last there will be, you will have a borrow taken from here, right? Everywhere you get 0. So your content of the AL register, okay, then BL register 1 3, okay, right? Then when you just AND it, okay, so the content of AL, which is the result from the previous operation, and content of BL, when you AND, do the AND operation, bit by bit AND operation. When you do bit by bit AND operation, definitely you get the result is 0. I think I expect you to do this, right? So 0 flag will become 1. Then you can see that number of parity bits also will be in such a way that parity bit also will be set to 1. I've understood this. Okay, so here you have to complete this. Okay, you have to complete this 07 minus FF. See what is the content of AL register. If you want to check, you can use a calculator. Okay, in this calculator, you can use this programmer. Okay, so put it in hexadecimal 7 minus FF. What is the result? Result is negative, right? Result is negative. That's why it is coming here as FF. So, but what will be in AL register? AL register will have 08 in that. Okay. So now use that AL register content. Okay, and then AND it with the BL register content. Okay. So AND 08 and so what is that in the BL register now? Can you see? Which is the question? BL register is 13H. BL register is 13H. Accordingly, you just have to do that 13H. So now you're going to AND 0000, 1000, and then 0001 and 0111. When you do AND operation, what you get? 000 and 0000, and then you will get 0000. Right? Okay. So now you can see there is no ones here. Parity, no, all zeros, right? Okay. So then definitely the parity bit will become 1. Right? Because of AND operation, your auxiliary flag, carry flag is 0. Okay. And carry flag is also 0. And 0 flag is 1, right? Why 0 flag is 1? Result is 0. Okay. And sign flag is also 0. And you can see the parity flag will also become equal to 1 now. Right? So you just have to do only this much for this. you will get 1 marks. And be careful that whenever these instructions are executed, check the value of AL. See, most of the students, I remember what they did is, everywhere they have used AL as 080808 only. And somewhere they get a wrong answers here. You have to be very careful with that. Okay. See what happens when you do addition here, your AL content will change. When you subtract here, AL content will change, because this will subtract and keep the result in AL. And that AL is value is used for the next AND operation. You have to be very careful. Most of the students, they did do this mistake. What they did, everywhere they have considered AL as 08 only. They are not considered this operation. And you lose marks in this. Right? Definitely you lose marks in this. Okay. Now the question is, what will be the output after following code is executed? Okay. This is very easy. The questions are all very easy in this. See. Hope all of you understood that flag register one.
Yes, sir.
Okay. Flag register one. Don't do any mistakes in that. Okay. Now let us go to the next question. See, what will be the output? Now this is like a debug. This is like a debug for you. Okay. Now you see here. First, what are you going to put in AX register? See, first step you see. In first step, your AX register, content of AX register is equal to 0202. Right? Okay. Now after that, same content, you're going to put it in a memory location 1234H. So offset address is 1234H. Now, in a memory with the offset address 1234H, in this memory location, you are having 02, and then can you tell me what is there in the next memory? See, this is, see, your offset address is 1234H, right? How does this data is stored in the memory? Tell me. In the memory location 1234, you have, I said it's the 16-bit, right? 16-bit value. So in 1234, you have the lower byte of the data, right? What is the lower byte of the data? 02H, right? So what is there in 12345? 1235 higher byte, yes or no? Are you understanding this? Higher byte, right? Higher byte is also 02 here. See, when this data is 16-bit data is stored in the memory with the offset address 1234H. I told you that in the offset address 1234H, lower byte is stored. In the next offset address 12345, its higher byte is stored. Right? Higher byte of AX is stored. That means in 1234, because values are same here. Okay. So in 1234, 02 is there. In 1235, sorry, 1235 here. 1235 here, you have 02H. Have you understood this? Okay. So now you see here, move CL comma 0 times, 02 times. Okay. Now it is given rotate right word pointer 1234H. See, word pointer means it will take the complete word from this offset address. So when it takes the complete word from this offset address, means it will take complete this lower byte and upper byte both. That means you're going to rotate 0202. Okay, how many times? 2 times. We'll rotate it 2 times. Rotate word pointer 1234H, not byte pointer. If it is byte pointer, then that will be only 1 byte you're going to rotate, right? So now the question is, what is the content of the question is, code is executed. Output means,
Sir, which byte will it rotate if it's byte pointer?
if it is byte pointer, it will rotate only this. It won't rotate this another 02. I've understood this. Okay. See, if it is a byte pointer 1234H, it will rotate only the content of 1 byte content of the memory, with the offset address 1, 2, 3, 4H. That means it will rotate only 1 byte, right? Since it is word pointer, so total of 2 bytes will consider to be 1 word, right? So that means it will rotate a word from offset address 1, 2, 3, 4H. See, for it to be a word, okay, it is both 02H and 02H. That is 0202 hexadecimal value now. Have you understood this? It rotates this 2 times. Okay, can you rotate this 2 times now? Now it will be 0, 0, 1, 0, sorry, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 1, 0, right? Okay, now rotate once. What you will get? Tell me. Rotate one. See, rotate twice. Can you rotate this? What happens? Rotate right. Rotate right twice. Come on. What will happen? This 0 will come to MSB, right? Yes or no? So I will remove 0 from here. Okay. I will remove 0 from here. And I will put it here. I will put it here. Okay. Then make a group of 4, 4. Right? Okay. Now again, second rotation. What will happen second rotation? Tell me. Rotate right. This is first rotation. Yes or no?
Yes.
See, I will write the original one. 0, 0, 0, 0, 0, 0. Sorry. I'm sorry. This has become 0, 1, 0, right? I have written wrong here. 0, 0, 0, 0, 0, 0, 1, 0, right? It is 2, right? Okay. Now, first rotation. I will do the first rotation. See, first rotation. I will do the first rotation. This type of question will come, right? So this 0 will come here, right? So I will remove this 0 and put the 0 here. Okay, then shift. Yes or no? So shift means I can just write it like this. This is what you get in the first rotation. Yes or no?
Yes, sir.
Come on. Right? Now one more rotation. Copy this, paste here. Okay. Now what you do? Remove this one from here and put it here. 1. Okay. Now make a bit of 4, 4. Make a group of 4, 4 here. See. Now second rotation is over, right? Can you tell me what is the value you get?
8080H.
You get 8080H. So what is the answer? Let us check whether our answer is correct or not. Yes, answer, right? Your AX register, okay? Now here you are having rotate word pointer 1, 2, 3, 4H. Okay, it is not the content of AX register, but content of the memory, okay? Content of the memory. Okay, because here ROR you said 1, 2, 3, 4H. You are trying to rotate the data from the memory. That means the memory data will be 8080H. That's all. So have you understood this now? This type of question will definitely come. 4 instructions will be given to you, okay? And you will be asked to find the output now. See here, your output you're getting from this instruction only, right? Because this is the last instruction. This instruction is the last instruction. Since this instruction is the last instruction, output will be definitely from this instruction only. So this is rotate right, word pointer 1, 2, 3, 4H. Because it is word pointer, then the data will be definitely 8080. Suppose if I give byte pointer, can you tell me what will be the result? Suppose if I said byte pointer, only that 02 you have to rotate, that's all. Okay, only 02 you have to rotate 2 times, that's all. Okay, if it is a byte pointer here, if it is a byte pointer here, right? Have you understood this?
So like if you put byte pointer over there, then the result will be 80H, right?
Yes, of course. Of course. 2 times. Just check. If you rotate 2 times, what you will get? You're going to rotate only that particular byte only. Okay? Right? The question is that what is the result after the execution of this? So here, if we say AX register will be 8080, this answer is little correction is required here, because you're not putting it back into AX register, right? Are you going to put it back into AX register? So if you want, suppose if you have move, okay, AX, comma, 1, 2, 3, 4, H. Now content of AX register is 8080H. Have understood this? Have you understood this?
Yeah, sir.
Now you tell me, what is the content of AX register? If I make this byte pointer, I'm making a small change here.
80H.
Come on, come on. I want the content of AX register, my dear. Don't be in a hurry. Don't be in a hurry. See what is there in the memory. What is there in the memory now? You are rotating only byte. You are rotating only one lower byte only. You are rotating only lower byte. Your upper byte remains same there. Next location. But when you copy the data from the memory, you are copying entire world. Now tell me, what is the content of AX register? Come on.
Sir, I'm getting 80H only.
80H.
Yeah, sir.
My dear, my question is, what is the content of the AX register? Is it a byte? Tell me. Is it a byte? It's a word, right?
So, sir, it will be 080H.
0,
080H.
080H.
No, 0080H.
Why it is like that?
Because it's.
This is what the mistakes you do. Now I understood why you're getting less marks. See here, listen. You are rotating 1, 2, 3, 4 H. What is that 1, 2, 3, 4 H? 0, 2 H, right? You are rotating the lower byte, right? Yes or no? What's the lower byte? 0, 2 H, right? You're rotating this byte, yes or no?
Yes, sir. Yes, sir.
When you rotate this 2 times, what you will get? 80, right?
Yes, sir.
You have understood this. That means what is changing? Only lower byte is changing. Upper byte remains same, right? The content in 1, 2, 3, 4 H remains same, right? 0, 2 only. So when you see, this is when I just execute an instruction move AX, comma, within the square bracket 1, 2, 3, 4 H. Now can you tell me what is the content of AX register?
It will be 0208H.
0, 2,
0280H.
0, 2.
80H.
Its upper byte remains same. You are not actually disturbing upper byte. That means your upper byte 02 will remain same. That in the AX register, you will have upper byte 02 remain same, but lower byte you are rotating right here by giving byte pointer here. By giving byte pointer here. See, this type of questions will come. Students, is very easy. I am putting byte pointer 1, 2, 3, 4 H. That means what is there in 1, 2, 3, 4 H only will be rotated. So this will become, after rotating, it will become 80H. Nothing will happen to upper byte. Okay, whenever you try to transfer into the AX register. Okay, so this will be 80H. Now I will give you one more example. Now suppose if I do move AL, comma, within the square bracket 1, 2, 3, 4 H. Now tell me what is the answer in the AL content of AL register?
80H.
80H. See, this type of questions will come. Try to understand. First of all, you should know how does the data is stored in the memory. Right? Listen carefully. I am trying to explain you this again. Right? See, suppose if I say, listen carefully, take this program. Okay? See what I'm doing. I'm first a content. I'll take another register. I'm putting BX. Okay? One data called as 1, 2, 3, 4, for example. Okay? Suppose if I write move, okay, move square bracket, okay, 4001H or say 4000H, okay, comma, okay, BX. Okay, tell me what this does now. This is going to store the value, a 16-bit value into the offset register. Right? Your memory will be something like, your memory will be saying this 4000 4000. Your memory will be something like this. I have explained this many times. Offset address, it will store the continuous locations 4002, 4003. Okay, these are all the offset address. This is where the memory is storing values. Listen carefully here. See. Now, how does this data stored in the memory? How does 1, 2, 3, 4 is which is there in the BX stored in the memory? First lower byte will come. What is the lower byte? 34H will come first. Then in the next location, okay, 12H will come. I've understood this now. Okay, this is the way data will be stored. Now suppose if I just change this a byte, for example, suppose if I say BL, then definitely I can't have 16-bit value here. If I say 12H, now definitely it will be BL, okay? Then definitely it is going to store only one byte. That means it is going to take only one location. That means this will be 12H is stored in this location, memory location. This is the way it stores. Have understood this, okay? You have to be very careful. I can see many students are making mistakes in this type of questions. It's very easy. See, what is the mark for that question? See, it is 4 marks. See, 4 marks. 4 marks. Properly, you know how the data is stored in the memory. Many students have that problem. How the data is stored in the memory. Right? Okay? That you have to be very careful. This type of questions definitely will come. Right? Okay? So, I think only students who are here is now benefiting from this session. I don't know in other section this will be done or not, but I'm trying to solve this because you know that how the questions are going to come for the midsem examination. Right? Okay. So have you understood this now? Tell me, those who are here, I think 16 or 15 people are here now. Are you understanding this?
Yes, sir.
Yes, sir.
Okay. Now I'm going to give one more question for the next session. I will give you one similar question. I want you to answer that. I want you to do that. Okay. Have you understood this? Okay. Fine. Now this is another similar question. Now can you do this? Don't see this answer. Can you see this? It is same to the above, whatever is given above. Don't see the answer. See, that is why I don't want to give the answer with any question. You will simply fire the question and answer and come. Now tell me how to do this. See, just see what is the AX content of the AX register when it is executed, when this is executed. Content of the AX register is 34 0056, right? Now, what will be the content of BX register when this register is this instruction is executed? Come on, tell me. You people are sleeping. What?
3456 only.
3456. Yes. So, what will be the content of BX register now? Come on, tell me. Do it. Do it. Do it. Use a pen and paper. Come on, do it. Give me the value. Come on. Come on. And of BX and 00FFH. What is BX? BX is 3456. Quickly, quickly, quickly. Come on, and it. Right? You people are sleeping, huh? What is that? 0, 011, 0100, 0101, 0110, and then do the AND operation of this. Next is what? 00FF. See, 0000 means definitely everything 00. You already know. Okay, you need not do the AND operation of this. Result will be 0 only, you know. And then FF. FF means 11111111. Same thing will come, right? Okay, see 1111 and 1111. Masking. What will be the result? Result will be definitely 00. Come on. 0056. Why are you taking so much of time? I don't understand. Do I have to do all these things? See, FF means 1 1, right? It is actually all 1 1 1 1 1 1. Adding operation with anything 1 1 means same thing will come, right? Adding operation with 0 means it will be 0. Definitely it will be 0 0 5 6. Right? How much time it takes for you to do? I don't understand this. Okay, move CL, 06H. So CL will be equal to 06H. Okay, now you see here, you are supposed to rotate this how many times? 6 times, right? Come on. Oh God, I don't know why.
Yes.
Huh?
Yes.
Can you get me the answer of the BX register? See, rotating 4 times, what will happen? Tell me. This is the value of, what is the result of BX is 0056, right? Now tell me, when you rotate 4 times, what will happen? Tell me. I told you, nibble swapping will happen now. I told this in the class. At least can you just hear that? Right? So can you tell me, when you rotate this 4 times, rotate 005x 4 times, what will happen? Tell me, come on.
5600.
Rotate, sorry, this is not rotate, this is shift, sorry, shift right. When you shift right, 0056 4 times, what will happen? Tell me. 4 times. Come on. 6 we'll do later. What happens?
The nibbles are shifted to the right.
Right. Then least significant nibble will become 0, right? This will become 0560. Yes or no? Come on. Yes or no? I'm not getting either yes or no from you. When you shift this 4 times, of course, what is asked is 6 times, right? First I want to see what we'll get after 4 times, then shift this bits again 2 times. See what are you going to get? 0000. After 4 shift you get 0101, 0110, 0000, right? This is after 4 shift. After 4 shifts. I don't understand why you are not able to do. Now do 2 more shift. What you will get? Tell me. Come on. You add 2 zeros here. You remove 2 zeros here. Then see what you will getting. What you are getting. Just shifting left to shifting right. Sorry, shifting right. Okay, I have done a mistake here. Shifting right. Shifting right means what will happen is, sorry, I will just change this. Shifting right, what will happen now? Tell me. Come on, tell me. Come on. I'm not getting answer. Shifting left I did now. Shifting right, what you will get? Tell me. Shifting right 4 times, what you will get? Oh God. BX. Initially 0056H. Right. See here BX value after ANDing 00FF, BX value will be 005X. Now you have to shift right by CL times, 6 times. Right? Now, first let us see after shifting 4 times what you will get, tell me.
Sir, you get 0005, sir.
Exactly. Why you are getting taking so much of time to tell me that answer? Most significant bit will be filled with 0000, right? So you will get 0005. Now can I shift it now 2 more times? Okay.
Yes, sir,
So
you
now
get 0001H, sir.
this is 0000 I'm writing binary 0101. Now shift it 2 times. Shift it 2 times means you remove this 2 and then you add 200 here. Now make a group of 4 bits. Okay, make a group of 4 bits. Make a group of 4 bits. See here. What's the answer now? Tell me. 0 0 0 1. This is what you get after execution of this statement. Let us check what is the answer. At least hope answer is there. See, it is not content of AX register, but content of instead of content of BX register. Make this correction. Okay, BX register 0001. See how much. See how much 4 marks you get out of this. You people are, I don't know. Most of the people may not do this. See, so easy. Just you have to debug this each and every instruction. You have to be very, very, very fast. The 100 n number of questions can be formed like this. N number of questions. Right? See, what you require to know this, what this instruction does. That's all. You need to know what that each and every instruction does. That's what I have explained to you here. See, that's what I have explained to you here. Right? Okay, see, what will be first step? AX register is having this. Okay. Now next, BX register is having this. Now take the AND operation of BX and 00FF. Okay. See, whenever you AND anything with 0 means 0. Right? Anything with F means same value will come. Okay. You will get 0056. And then CL will be having 06. Then shift right by CL times. So BX content is this one. Okay, it is been asked to shift 6 times. Okay, now you know what will happen when you shift four times. Okay, you know that one nibble will go. Okay, the lowermost nibble will go and uppermost nibble will have that 0000. So then definitely you get 0005 here. Now put it in the binary if you want to see exactly what's going to happen, right? Okay, so you will get 000000000000101. Now once again shift right 2 positions, right? So what will happen? That two least significant bits will go out, and same time two zeros will be added to the most significant bit. Now once again make a group of 4444 bits, write the hexadecimal value. That's all. That's all, students. It's very easy. It's not difficult at all. Right? You will get 4 marks if you do that. 4 marks if you do that. Have you understood this? Okay. Okay, fine. Okay. Next. See, till here you have now this see how many marks programs are there. Let me see that here. Okay, this anyway, this may not be there for this test. Pins and signals we are not done. Since pins and signals we are not done, I don't think you will get any questions on that. Okay, so that's why. But programming will come now. If you see this programming question, 7 marks, then okay, 7 marks, and then one more 7 marks, 14 marks, and then remaining in this place you will get 3 plus 3, 20 marks. So 20 marks will be more, maybe around that. You may get in this question paper it was 20 marks, but this time question paper we don't know, right? So you can expect around 20 to 25 marks only programming, and it is, I think it is 25%, right? 50 marks it is, right? 50 marks it is. That means definitely 25 marks will come. More than about 20 to 25 marks will come for the programming part. So don't decide to leave programming. You have to do something, write something on the programming. See, what is the program which came during 2022 and 2023? Just one last year only. See here. Write an ALP to find the smallest and the largest number in a given array. Okay, this is something you have done in the lab, right? Yes or no? Come on, tell me. Right? See, you are going to find out the smallest number, and also you're going to find out the largest number. Right? Okay. So now you can use two compare statements, okay, to compare to get a smallest and largest number. How we are going to get largest number? You have done this program, and I have explained you this program in one of my video, how to write a program to find out the largest number. Okay. Now find out the smallest number is the reverse. That's all. I told you that instead of jump on no carry, you just change one statement out of that, it will become smallest number. So you'll be combining both smallest and largest program as a one program, and that is going to be the answer. So you will get, if the program is correct, you will get 7 marks. You'll get 7 marks. Okay, what is the another program came? Write an 8086 assembly language program to check whatever key pressed from the keyboard is numeric keys or not. Okay. If the key press is numeric key, then it should display numeric key pressed. If the key is pressed is something other than numeric key, it should display non-numeric keys. Here you're going to make use of interrupts, DOS interrupts. Okay, DOS interrupts you're going to use. You're going to display program also is going to come. Everything you need to do in this. Right? Okay. So don't buy at this program. This buying will not work. That's why I'm telling you. Okay. So you have to write proper logic and then do it. Okay. So I think I will cover this in my next session. It's already 9:47 here. So whatever is done so far, is it fine for you? I will try to do this program. I will teach you just writing step-by-step process for writing an answer for this question. You must have been exhausted now, right? Yes or no?
Sir, once can you open that byte pointer solution?
Byte pointer solution. Yes. Where? This one?
Yeah, I'll just take a picture. I didn't write it down.
No, I will do one thing. Okay, I can take it down. Yeah, where is that byte pointer? I have changed it to byte pointer, right? This one, right? This one.
Yes.
Yeah.
Sir, below that.
Okay, here it is, right? Yeah, correct. 80H. This is what the changes.
Yes, sir. Thank you.
Okay, can you write the program yourself for this question? For this question, can you write the program yourself? See, I don't believe in giving answers, because you will simply buy at this and come. And definitely this same program is not going to come. Right? So I want you to write a program yourself. Write it yourself. See that you will be able to write the program for this or not. Right? Okay. I'll put this, both the questions. No point in biting the program, okay? Write it your own. Write it on your own. Okay? Fine. So next session I will explain you this program, how to write this program. I will not just see that put the program at a time and explain. I will try to write program step by step. You see that how I'm writing the program. Follow the similar way of writing the program. Okay. So today is already 9:50. So if you have any doubts, you feel free to ask me the doubts. Okay. Anything you want to discuss or any doubts where you have the problem, please tell me. Right. So independently try to solve these questions. Still, if you have a doubt,
Sir?
see this diagram and all, this may not be there for you. Okay, this time. Okay. Yeah. Tell me. Yeah. Please go ahead. Yeah.
Sir, while doing division, we do word divided by byte, right?
Exactly. Always word divided by byte, and always double word divided by word, and always q word divided by double word.
Sir,
Right?
and then in one of the slides you showed in 16-bit division,
Yeah.
both are word only, sir.
No problem. Then definitely you have to convert. You have to put the data in dx ax. It will be converted into a double word by putting higher order word into dx register and lower order word into ax register. It will be 32-bit only. It will be double word only. I've understood. Even though
Yes.
if it is a word, but definitely your higher word will be 0000. I've understood this.
Yes,
Okay.
sir.
Yeah. If somebody can do very good program, definitely I think you will be able to score well in this. I'm sure about it. Right? We'll give similar programs only, not any tough. We'll give programs something which you have already done in the lab and also in the class. Right? We'll not give anything other than that. That's why we are telling you in every lab that you do the lab sincerely. Do not try to do a copy and paste. Right? Do some preparation for the programming also. Try to execute the program by yourself. Write the program yourself. Now you know every instructions, right? Every instructions you know, right? Is there any instruction which you don't know? Every instructions we know. Every instruction we are covered in the class now. Right? We have covered jump instruction. We have covered you have covered move instructions. We have covered even string instructions also. How to use the string instructions, that also we have covered. Right? Everything is covered in the class now. Just try to know that what the string instruction does, what each and every string instruction does. Remember that, right? I have made a video and watch that video again and again to understand what is the string instruction. Have you understood this? Right? Okay. So I'm sure definitely if you practice, definitely you will be able to do good in this. Okay. So how to practice a program? Right. So first thing, to write a program, what you need to know about this basic instructions are enough. We're not going to ask any questions which require some special instructions. No. Move instruction, right? Add instruction, subtract, jump, loop, right? Decrement, increment. You need to know what are all these instruction does, right? Okay. Then definitely I'm sure you'll be able to write a program. And first of all, you need to write a program of your own. At least some 5-6 programs you take only question and write answer by yourself. If not writing, you try to type it in TASM and also type it in the MO8086 which I have actually given you. At least you do that. I'm sure you will get very good programming practice. Right? See, programming will come for your midsem exam, okay, and then it will come for your compre exams. These two places programming will come, right? And then maybe in lab compre your programming may come, but in main compre we may not give much programming question because there are so many things we are going to cover after midsem, that memory interfacing, IO interfacing, all these things we are going to cover, right? Okay, I have floated all these videos on my channel. All of you refer to this again and again. Watch 100%. You will be able to understand very well. Okay. Okay. So next class, what I will do is I will try to solve some of the programs which have come in the previous year question paper. I also have another set of questions here. See, another set of questions. Okay. And some of the questions which came for makeup exams. Okay. Don't try to come for makeup. I'll tell you, you will never be able to score at any cost for any reason. Don't think that your makeup will be easy. Makeup will be hell for you. That's why. Okay. So at any point, see, take care of your health very well and come for the main exam only. You will get better score. Makeup question will be little more tougher than the regular exam, because this students, see, some students may be genuine, some students may not be genuine, right? That's why we don't want students to take a chance, that they may think that same questions will come for the makeup exam. And you all know, you may be having some experience also. That's why never ever come for the makeup exam. Come for only main exam, which will help you a lot to score, right? Okay. So all the best. I think today we will actually complete our session. Hope this session has helped you, right? So I think finally I have around 13 students, right, at the end. So out of 95 students, the only 13 students are really interested to learn. I will definitely help you. Don't worry. Whatever doubts you have, whatever is, wherever you find a problem while writing a program, or whenever you find problem in solving any questions, you feel free to come to me. I will help you in understanding that. But never ever by heart the things. It's not going to help you at all. 100%, right? You can feel after writing the exams, right? Little tough. It is true that microprocessor is little tough, but whenever a course is little tough, definitely you have to put more efforts, right? And that efforts will never go waste. But if you don't put more efforts, then definitely you may not be so successful. That's why you put effort. Sometimes you may put effort, right? But still marks are coming less. Then just see where you are making mistakes, right? Okay. So how I can guide you that how to prepare smartly, okay, than having more hard work and when preparing it, right? So as I told you, for programming, first you need to know about the instructions, okay, and then you need to know about logic, okay, and then if you don't know both, if you know both, programming will be very easy, right? Okay. So next, I'm going to take 2 more sessions now. In both the sessions, I'll be doing only programming. 2 hours, 2 hours. That will be in the next week. I want to take one big session before the exam. Right? Okay. Those who are interested, they can join. Have understood this. If really if they want to learn, they can come. Okay. So all the best and practice programming. Okay. See you then. Good night.
Sir,
Yeah. Tell me, Karishma. Tell me.
sir, in the next class, could you like do file handling question also? Like
Of course,
to
that's
read and
interrupt, right?
write.
That's interrupt, right?
Oh yes, sir.
Yes.
Like to read and write from the like in the
Of
files.
course, it is just an interrupt. I will explain you step by step how to do that.
So, and sir, in exam, will they give the interrupts like what to use? Because like we don't know all the
Okay,
interrupts.
okay, of course, because they're remembering, that file handling and and system date, system time and all. Okay, if at all such question is given, it will be what are the functions will be given to you.
Okay, yes.
But you need to remember that string, taking string from the keyboard, taking displaying string on the console, taking a character from the keyboard, displaying a character on the console. You need to remember that actually.
Yes.
Okay,
Yes.
I've understood this. Okay, but when it comes to that file handling and all, there are so many interrupts you use and so many registers you need to remember, right? Okay, so in such cases, it's very difficult to remember those interrupts and corresponding registers. In such cases, it will be given to you.
Okay, yes.
Okay,
Sir, are all the interrupts covered in your video?
interrupts. See, there will be separate chapter on interrupts. During that, you are going to cover interrupts. But these DOS interrupts, right? These DOS interrupts, we'll be covering in the lab. Most of the time, it will be covered in the lab, not in the class.
No, sir, like in the YouTube video which you sent, are all the DOS interrupts covered in that?
No, I'm not. I see. See, do you remember? I have actually just 1 minute. See, I will try to share my screen. I will tell you how to remember that interrupts. I have sent you one link. Hope you understood. Okay. See here. Do you can you see my screen? Can you see my screen?
Yes, sir.
Okay. See, I have shared it. I have shared this with everybody. Right. Right. See, this manual is
Yes.
given to you in the exam. This manual, na, not in midsem exam. In the compre exam, this manual will be given. This manual will be given to you. This entire manual, hard copy will be given to you. Okay. Now, if you want to know about interrupt, see, suppose interrupt 21H. If you click on interrupt 21H, this is going to give you more information about interrupt 21H. See here. So the function 1, okay, this is read a character from the keyboard. This you know, right? You put 1 into H register, call interrupt 21H, right? And it says that the whatever key pressed will be stored in the AL register. Interrupt 02, right? Interrupt 21, function 2. It is actually displaying a character, right? So whatever character to be displayed, you have to put it in the DL register. Have understood this, okay? So this is what done here. See, one example is given. Similarly, when H is equal to 5, output character to the printer. Anyway, these things are all, you're not doing it, right? Now, after that, you come here, certain things you are using. This is for all these things are not required. See, there are some date, display and all. System date. See, system date here. See, system date. System date. System date. You are going to put 2A into age register and call the interrupt. And what happens? Your year will go and sit in CX register, and your month will go and sit in DH register. Day will sit in the DL register. Okay, and day of the week also it will come. It will sit in the A register. I've understood this. Then accordingly you try to display it. System time. See, 2C for system time. Okay, so certain interrupts only required for you. Not all the interrupts you need to remember. Right? See, read from the file. Can you see a read from the file? See, interrupt 21H. Okay, see, closing a file. Right? Now you have this opening a file. See, opening a file, you have to put 3DH. Okay, so now when you moment you execute that, okay, see here, you have to put 0 into AL register. If you put 1 into AL register, it is for writing, and if you put 2 into AL register, it is read and write. Okay, then you put 3D into H register, call interrupt 21H. Your file will be opened for both read and write. Like this you have to remember. Okay, so I will explain this all these things. I will explain you in my next video system how to read system date and display the system date, and how to read system time and how to display that. Okay, and very importantly, I will explain you one more program that how to take a values from the keyboard and display the result, whatever it is, whether it is addition, multiplication, display the result on the console. This is also a very important program, and it's very easy. Okay, little bit practice you have to do. Okay, so we will see that during our next class. Okay. So any other doubt you have? See, this gives you, this hard copy of this will be given to you. Don't worry. Okay, but you don't require all the interrupts. Only few interrupts only you have to whichever you are using, you have to use it from this manual. And instructions, right? Only few instructions only you're going to use, like move, add. All those are quite highly rememberable instructions. You can remember it, not a problem. Okay, because last 2-3 weeks we are doing only instructions in the class, right? So all those things are required for you, and you need to remember that. See, move instruction, all these instructions are straightforward, right? Okay, so string instructions are something we need to remember. Okay, so all those things will come only through the practice. Okay, so when you write a program, you will be able to learn all those things. Fine, so shall we stop today? So we will meet again. Definitely. Any other questions? See, whenever you try to practice for microprocessor, you may come across with certain things which you may not understand. Immediately you just write it down. Okay, you write it down, and then you just ask me. I will answer that. Right? Don't leave it as it is. Don't give up anything. Whenever you feel that you are not able to do this, okay, then you just write down that you have a problem in this point. You ask me, I will help you that. Fine? Is it fine? Okay. Okay, so good night, all the best. Okay, prepare well. Okay, right. Okay, see you then. Bye bye.
Thank you, sir.
Thank you, sir.